Imagine, for a moment, that you were a squirrel. Not a cartoon squirrel, a real one. A creature weighing less than a bag of chips, with a brain the size of a walnut. Now imagine this. Over the course of a single autumn, you have buried 3,000 acorns across a forest the size of 50 football fields. No GPS, no map, no sticky notes on your fridge. Just you, the soil, and a desperate need to survive the winter. 3 months pass. Heavy snow has covered the entire landscape, transforming every tree, every rock, every familiar landmark into an identical, white-mantled shape. The world you knew has vanished, and yet, with pinpoint precision, you dig through the frozen ground. You find your first acorn, then your second, then your 100th. Not once, not twice, but hundreds of times, you return to the exact locations where you hid your treasure. This isn't a story about luck. This is not coincidence. This is memory. Now, here is the uncomfortable truth we have been avoiding for centuries. We humans have a massive ego problem. We told ourselves that memory, real memory, the ability to recall specific events from the past, was our exclusive gift. We convinced ourselves that animals were simply running on autopilot, driven by blind instinct alone. We called it animal nature, as if it were something lesser. But science has finally caught up to what any dog owner already knows. Your pet is not just reacting. They're not just responding to stimuli like a mindless machine. They are remembering. They remember your scent. They remember your voice. They remember the sound of your car pulling into the driveway after a long day. And what they remember will absolutely blow your mind. Because in the next few minutes, I am going to take you on a journey. We will explore a bird with a brain the size of a pea that has a filing system better than any computer. We will meet chimpanzees who remember puzzles from nearly 3 decades ago. And we will dive into the mind of a creature so alien that it keeps memories in its arms, literally. So stay with me, because the secret lives of these forgetful geniuses are about to rewrite everything you thought you knew about intelligence. Let us begin our journey with the undisputed rock star of memory research, the black-capped chickadee. This tiny bird weighs less than a single A battery. Its brain is roughly the size of a pea, and yet, every autumn, it hides tens of thousands of seeds across its territory and finds them again months later with an accuracy that would put our own spatial memory to shame. For decades, scientists were baffled. How could such a small brain perform such a complex task? We knew about the hippocampus, the memory center of the brain, but we had no idea how it worked at this level of precision. Then, in a landmark study, researchers at Columbia University developed a breakthrough solution. They created a lightweight, miniature recording device small enough to be carried by the bird without hindering its natural behavior. This device allowed them to record the activity of hundreds of individual neurons in the chickadee's hippocampus while it performed its caching ritual in a controlled arena. And what they discovered was nothing short of astonishing. The researchers found that the hippocampus does not simply create a general map of the environment, as we once believed. Instead, it actively generates a unique neural signature for each individual caching event. They called these signatures neural barcodes. Think of it like a QR code. Every time the bird hides a seed, a specific, sparse burst of neurons fires in a unique pattern. This pattern is so distinct that even for 2 seeds hidden only inches apart, the barcodes are completely different and entirely uncorrelated. This is a critical evolutionary innovation because by creating a unique barcode for each event, the brain effectively prevents interference between similar memories. It is a filing system that allows for the rapid storage of thousands of non-overlapping, easily retrievable memories. Now, the truly mind-blowing part of this discovery is what happens during retrieval. When the chickadee returns to check on its stored food, the exact neural barcode that was created during storage lights up again. This reactivation serves as a signature of memory recall. The bird does not just remember the general location. It re-experiences the specific event of hiding that particular seed in that particular spot. This phenomenon provides a direct neural correlate for what we call episodic memory. In human psychology, episodic memory is the memory of a specific event, the what, the where, and the when. And now we have evidence that a bird with a brain smaller than your thumb possesses a version of this same capability. Let me put this into perspective. Think about how easily you forget where you parked your car at the mall. Now imagine remembering the exact location of thousands of individual items hidden months ago, under snow, in a landscape that has completely changed. The chickadee outperforms most humans in this specific domain, and it does so with a fraction of the neural hardware. So what is the takeaway here? It is this: memory is not about brain size. It is about architecture. Evolution found a way to build a hyper-efficient filing system inside a pea. And it works better than most humans' memory after a bad night's sleep. This discovery has profound implications for our understanding of intelligence. It forces us to ask, if a chickadee can do this, what else have we underestimated? Now, let's shift our focus from birds to our closest living relatives, the great apes. We're going to explore a question that touches on the very essence of memory. How long can it truly last? We have all heard the stories: elephants remembering faces for decades, dolphins recognizing human friends after years apart. But the scientific evidence behind these claims is now more rigorous than ever. In a remarkable study published in 2024, researchers at the University of St. Andrews put chimpanzee memory to a test spanning nearly 3 decades. They revisited a group of chimps who, as juveniles 27 years earlier, had learned a complex symbolic matching task. This task involved associating specific colors with specific geometric shapes, a form of arbitrary rule learning that requires genuine cognitive effort. You might expect such an old memory to be completely gone. The brain changes over time. Neurons connections weaken, and in some ways, the memory was indeed faded. The chimps did not recall the specific symbol pairs they had learned decades ago. They could not produce the correct associations on their first attempt. However, something even more fascinating happened. When these apes were reintroduced to the task, they relearned the rules up to 4 times faster than chimps who had never seen it before. This phenomenon, known as the savings effect, is a powerful testament to the brain's enduring plasticity. The chimps did not remember the exact details, but they remembered the schema. They remembered that there was a solution to be found. They remembered the general structure of the puzzle. The neural pathways, built decades earlier, had remained dormant but ready to be reactivated. This discovery is complemented by another study showing that apes can spontaneously recall a one-time, non-goal-directed event after a delay of up to 50 weeks. When cued, they remembered an event they had no reason to remember. Together, these results paint a picture of memory not as a perfect recording, but as a durable, structural foundation. It is like a muscle. It fades with disuse, but the underlying architecture remains, allowing for rapid rebuilding. In the animal kingdom, experience truly is currency. Even when the details blur, the wisdom stays. But just when we think we're beginning to understand memory, nature throws us a curveball. We have been talking about vertebrates, animals with backbones and centralized brains. But what about the creature that completely rejects the blueprint of biology as we know it? I'm talking about the octopus. A common octopus has 9 brains, 1 central brain and 8 mini brains, 1 in each of its arms. And here is the twist. Each arm can make decisions independently, reacting to sensory input without consulting the central brain. It is as if each arm has a mind of its own, capable of autonomous action. But how do they learn? While their arms can react independently, the central brain is essential for learning complex tasks like navigating a maze or opening a jar to retrieve food. In operant learning studies, the octopus's brain guides the arm to make the correct choice. However, once that memory is formed, its execution is decentralized. The information is distributed across the nervous system. This makes the octopus's memory a collaborative effort between the central brain and the peripheral nervous system. Furthermore, the brain is not the only repository of memory in an octopus. In a series of fascinating experiments, an arm that was trained to perform a task and then surgically removed from the body still responded to stimuli in a learned manner. This suggests that memory traces can be stored in the peripheral nervous system of the arms themselves, independent of the central brain. This is decentralized memory in its most literal and extraordinary form. This discovery forces us to ask a fundamental question: where exactly does memory live? If an arm can remember without a head, then maybe our entire definition of memory is too narrow. We assumed memory was a file stored in a single folder called the brain. But for the octopus, memory is more like a recipe that gets copied to every kitchen in the house. That is both a terrifying and a magnificent thought. This brings us to the million-dollar question. Is any of this just instinct? Are animals simply programmed to do these things? Scientists answer this with clever experiments like the cache recovery paradigm. They let a bird, like a scrub jay, hide food in an arena. Then, while the bird is not watching, they secretly move the food to a new location. If the animal goes back to the original, empty hiding spot, it is clearly using its memory of a past event. Instinct would not know the difference. Instinct does not get confused. Memory does. And that confusion is the smoking gun of a complex inner world. So why does all this matter beyond the wow factor? It matters because we share this planet with billions of minds that are not human. Every time we dismiss animal behavior as just instinct, we rob these creatures of their cognitive complexity. We ignore their capacity for joy, for relationships, and for a past that they carry with them. Memory is the thread that weaves the past into the present. It is what allows a mother elephant to lead her herd to water during a drought. It is what allows a lost dog to find its way home across hundreds of miles because it remembers you. So the next time you look into your pet's eyes, remember, they are not just looking at you. They are recognizing you. They are recalling every walk, every meal, and every scratch behind the ear. In that moment, you are not just an owner. You are memory. And that perhaps is the most human thing of all. If this video made you see the animal world differently, if it made you appreciate the minds that share our planet, then please do me a favor. Hit that like button. It helps more people discover these incredible stories. And if you want to join us on this journey of discovery, subscribe to this channel and turn on the notification bell. There is so much more to explore together. Thank you for watching. Stay curious. And never forget, the animals around you are remembering you too.